Last section of Unit B, just before our test. So the thing we've been doing is a lot of graphing. We'll have some graph stuff involved in this unit, but what we're going to end with here is some things that you can do with functions. So we've been dealing with functions this whole unit, moving them around, stretching them, shrinking them, absolute value of them, all of that good stuff. So now we're going to talk about what we can do with our function notation. So the first thing we're going to do we're going to talk about the operations on functions. Basically, there's 5 operations of functions. The first 4, I think, are going to be pretty easy to link to prior knowledge for you. It's not going to be too big of a deal. It's the 5th one that is new, probably the most important one of the 5. So we'll spend a little bit more time. We'll slow down a little bit when we get there. So the first thing is, I've got my notation here. So this first one is function addition. So when you see this notation, you've got the F, you got the G, they're being added inside the parenthesis. All this means is that you can simply take the 2 functions and add them independently. So f of x plus g of x. Okay, so function addition, all we're doing is going through what does this notation that you're going to encounter here, and when you take pre-calculus, and for any of you that are blessed to go to calculus, you're going to see this notation over and over and over again. So that's going to be part of your life. But all it means in this case of addition is you can separate the 2 functions and you can add them. The same thing for the subtraction. When I have f minus g of x, I can take f of x and subtract g of x. Whether I do that with the functions themselves or whether I do that with the values, we are going to encounter both of those situations in our examples. The next one is function multiplication. Same thing. I can take each individual function and multiply them together like that. So the notation, we're just linking it up with what we already know. The last one's the quotient. So I've got f of x in the numerator, g of x in the denominator. Now the quotient we do have to be a little careful on, because we know, and we will talk about this more when we talk about rational expression or rational functions in the 4th unit. But for right now, we know that the denominator of fraction cannot be 0. If you pop that into your calculator, you try to divide by 0, it's not going to work very well. So this one is the only one of the 4 that affects the domain. So you have to remember that g of x cannot be equal to 0. That'll be something that is a domain restriction. So any values of g, any x values that you plug into g that create a 0 y value, you will leave out of the domain. Now, I'm not going to focus on that too much because we haven't talked about rational functions in detail, but you might brush up against it as we go through. So first thing we're going to do with these 4 basic functions is we're going to talk about, is everyone caught up? I don't want to go too fast, but I also don't want to bore you more than I need to with this stuff here. So if I start moving too fast, please just raise your hand, wave it around a little bit, let me know. First thing we're going to do here is we are going to deal with using this these function concepts when I know the value I'm plugging in. So here, what my example is going to be is I've defined a function f. F is the absolute value of 2x plus 1. I've defined a function g as x squared. And what we're going to do is we're going to find f plus g at the value 2. So what I'm going to do to evaluate this, firstly, is I'm going to separate this using the properties that I've just showed you, that I can consider each of these things independently. I can evaluate the function f at 2 and then the function g of 2 independent of each other, and then just add the results that I get. And that's what we're going to do on this first one. So we've talked about plugging in numbers into functions. This isn't anything new or different than stuff we've done dozens of times already. So what I'm going to do is I'm going to take 2, I'm going to plug it into each function. So the first one, I've got the absolute value of 2. I'm going to put some parentheses where the x is. This is how I like to proceed. That way I don't mess up any negatives. And then plus g is x squared. So here's my parentheses squared. And both the places where I've got those parentheses, I'm going to plug a 2 in. And now it's just determine the value. Not anything that's, I think, too big of a deal. This is college algebra. You've evaluated expressions hundreds of times before. So inside the absolute value, 2 times 2 is 4. 4 plus 1 is 5, so this is the absolute value of 5. Here, 2 squared is 4. Absolute value of 5 is 5. 5 plus 4 is 9. So if I made the function up that was comprised of the function f plus the function g, when I looked at the graph of it, at the value at the x value to the y value would be 9. So I just want you to do, you're going to do one of each. I don't think this is anything too shocking. So we'll do these one at a time, so you don't have to work ahead if you don't want to. Probably prefer that you don't. So go ahead and do exercise 1. All right, I'm going to get started. Check your work with my work. Whatever question occurs to you to ask, please don't be shy. Ask whatever you need to ask. So I've got f plus g of -5. So again, firstly, this is f of 5 plus g of 5. I'm going to evaluate these things separately. So the function f is the absolute value of 2. I'm sorry, it's not 5, it's -5. I'm starting off strong today, just like last time. So I've got 2 times my parentheses plus 1 in the absolute value, and then plus my parentheses squared. And I'm going to put a -5, because that's the value I've asked about, into both of those. So 2 times -5 is -10. -10 plus 1 is -9. -5 times -5 is 25. And 9 plus 25 is 34. So that's the value that you should get out of that. If you've got a question, ask it. If you feel pretty good about that, then do exercise 2 for me, please. So this time I've got a function subtraction. So I've got the function f evaluated at 8 minus the function g evaluated at 8. So the function f is 2 times my x value plus 1. My function g is my x value squared. In this case, the x value I'm plugging in is 8. And so in the absolute value, 2 times 8 is 16, plus 1 is 17. So I have the absolute value of 17 there. 8 squared is 64. So 17 plus 64 is 81. Is that true? No, plus. What is wrong with you, Perkster? Oh my goodness. Minus. We just need to start the whole video over. 17 minus 64, sorry, everybody, is negative 47. Probably need to go have some sort of scan done. All right, go ahead and do the multiplication problem. Oh, maybe one of you should just come up and start writing. You're doing better than me. Right, so f of 4 times g of 4. So f is 2 times what I'm plugging in plus 1. I'm multiplying this time times g, which is what I'm plugging in squared. And so when I plug in a 4 into each of these, in the absolute value, 2 times 4 is 8, plus 1 is 9. I have the absolute value of 9. 4 squared is 16. And so then 9 times 16, I believe, is 144, but clearly I'm not doing great today, so correct me if I'm wrong. Okay. We doing all right so far? Aside from my blunders. All right, last one. Do the function division, and then we will be done with plugging in a value in for these, and we'll talk about what to do in the general sense. So my function is f of 2 divided by g of 2. So it's a quotient function. So f of 2, I'm going to take my absolute value, and I've got 2 times whatever I'm plugging in plus 1. In the denominator, I've got whatever I'm plugging in squared. This time I'm plugging in 2 again. We did this in the first example. 2 times 2 is 4, plus 1 is 5. The top is the absolute value of 5. The bottom is 4. And so when I do the absolute value of 5, I get 5 over 4, or 1.25 if you are a fan of decimals. Okay. Anybody struggling so far with plugging values into our functions? Okay. Speak, please, speak, because you're going to have a test next class. I want you to do amazing when I toss a couple of these on the test. All right, going down to the bottom of this page then. All right, well, what do we do then if a value is not given? So I've defined 2 new functions just to keep things spicy. And so now we're going to do the function addition. That's going to be my example, and then I'll have you do a subtraction, and we'll see what's on the next page for us to encounter. So all this means then, when I have my functions, is I'm going to take my f of x plus my g of x. I'm going to do that notation. And then I'm going to substitute. I don't have any values to plug in, so I'm just going to use the function themselves. So f of x is x squared plus 5x. This is function addition, so plus. Then g of x is 2x minus 7. So I've just plugged the appropriate function in the appropriate place. At this point, if there is any simplifying you can do, like in this case, we have like terms, or if you can distribute something, then go ahead. If there's not anything that you can do, then you are done with the problem. So on this one, my function that would define the addition of f and g is given by x squared. 5x and 2x is 7x, and then minus 7. And there we go. if we were to graph this, which that's a little bit more advanced, graphing things like this right off the bat. But what we could do is if we were to graph each of these things independently and then graph this, we would notice every point on this new graph, at every x value, it's just the sum of the x values you would get independently. So your new graph would behave in a similar fashion. Be that as it may, do exercise 5. It's a function subtraction. So be careful with that negative. That's why I'm having you do this problem, to make sure that we're doing all right with our negatives. All right, so I've got g of x minus f of x, whatever that is. So note the order. So g of x is 2x minus 7. I've got minus everything that comes next. Here's where you need to be careful. Negatives always throw us for a loop at some point. So just so that I don't mess this up, I'm going to put some parentheses because I'm subtracting everything that comes next. And what comes next is the x squared plus 5x. So then I have the 2x minus 7. I'm going to distribute that negative. I have negative x squared minus 5x. This is the most common mistake students make on this problem when I throw this on the test, is forgetting that that negative applies to every term in that polynomial. So if you made that mistake, that's okay. That's why I put this problem on here, so that we can learn and we can not make that mistake in the future. And now I'm going to collect my like terms. I'm also going to write this in descending order, which in my book in this class is an optional step. So if your terms are not in descending order, that's fine. But I'm going to put the negative x squared first. Then I have 2x minus 5x, that's negative 3x, and then minus 7. So far, so good. Anybody got any issues for me right now? Because we're going to practice this a little bit, because being conscientious about this is an important thing for us to do. So I'm not seeing any hands, so I'm rolling to the next page. At the top, exercise 6. Go ahead and do that function multiplication with our two functions from the previous page. The reason I put this problem on here is just so that we could real quick review an introductory algebra skill. So I've got f of x times g of x. So f of x is x squared plus 5x. G of x is 2x minus 7. I believe I've remembered those right. So in this case, there is something more that I can do. You know, multiplication, there's not always going to be, but since these are both polynomials, I can go ahead and FOIL these two. So when I go ahead and do that, my first x squared times 2x is 2x cubed. My outers, x squared times negative 7x is negative 7x squared. My inners, 5x times 2x is plus 10x squared. And then my lasts, 5x times negative 7 is negative 35x. I do have like terms that I can combine to make this look a little bit simpler. So I have 2x cubed plus 3x squared minus 35x. Okay, so hopefully I just triggered some memories for you that you can carry forward as you're doing problems. Don't forget to do any simplifying that is possible to do. If you have a question, ask it. If not, move on to example 7. There are two questions here. If you don't know how to recognize the domain, it's something we talked about in intermediate algebra, but I know that might have been like 3 months ago for you. At least do the first part, and then we'll talk about how to find the domain. Okay, so this one is f of x divided by g of x. It's the quotient function. And so setting up the quotient function, this tends to be the easiest one to do. My f of x is x squared plus 5x. My g of x is 2x minus 7. There's no simplifying that I can do there, so that is done. The kind of the hard work of this problem is what's the domain of the new function. And so notice all I've got is in my original functions are x squares and x's. The original domains are negative infinity to infinity. There's nothing going on, but I do have a problem down here. My denominator cannot be 0. So if you remember your intermediate algebra, or maybe this will bring you some flashbacks, what we do is we say, okay, the 2x minus 7, that cannot be equal to 0. So I'm going to add the 7 over. The 2x cannot be equal to 7. I'm going to divide by 2. The x cannot be 7/2 or 3.5 if you prefer. So I'm going to write that as an interval. So I'm going to take my negative infinity to infinity, which is the whole real number line, and I've got to cut this one value out. So the way we do that, again, if you were in intermediate algebra at Polk State, you've seen this, but it might not be fresh in your memory. So to the left, that's negative infinity to 7/2. Use a parenthesis because we are omitting that. Then union 7/2 to infinity. And that's how we write that we are omitting that one value from the number line. Okay, so just for time's sake, I've got just a couple more problems we're going to do because I don't want to shortchange the other operation we have to talk about, which is probably the newer one and the less familiar. But I do want to just make sure I let you know what to do in the instance that you have functions that you can't maybe do any simplifying. So what I would like you to do, if you don't have any questions, is exercise 8. I've given you 2 new functions and asked you to do the addition function, please. So on this one, I've got f of x plus g of x. So f of x is the absolute value of x plus 9. G of x is 5x minus 8. Here's the thing. The absolute value, that's not parentheses. You can't just drop those. Okay, that has meaning. So there's no like terms I can collect. I can't just add that x and that 5x and get 6x. So if you did that, again, that's why we're talking about these problems here before you engage the homework. That problem is done. I can't simplify that any further. So one more example of this, please just drop down below to exercise 10, the multiplication function with those same 2 functions. So this is the multiplication function, f of x times g of x. Once again, f of x is found in the absolute value of x plus 9. G of x is 5x minus 8. And again, I just wanted to once again make the point, these absolute value bars can't just be dropped. I can't start foiling. So again, don't try to do more work than the problem requires. You are done at this point. Any questions before we're just about to wrap up adding, subtracting, multiplying, and dividing functions? We're almost done. I'm going to skip exercise 9 and 11. If you want to do them and come by the office and see if you did them well, that is totally fine. Just saving us a little time. So now to end our discussion of adding, subtracting, multiplying, dividing, I've got a graph. The only difference in this and what we've done before is we're going to use the graph to find the values instead of plugging them into an equation. So go ahead and do those 4 examples. Give it your best shot. See how you do coming up with the addition, subtraction, multiplication, and division. Reading the graph. So I'm going to get started. All this is reading the graph. If you're having trouble reading graphs, then please let's talk. I think you've seen that that's a super important skill from all the graphing we've done in this first unit, and it's not going to get any different when we go on to the next units. So the addition f plus g of 2, I'm going to separate into f at 2 and g at 2. So the function f is the orange absolute value graph. What is that function's value at x is 2? Yep, so here's x is 2 right here. I'm just going to make a little pink dot. And so 1, 2, 3, 4. What is g's value at 2? Okay, 1, 2, 3, 4, 5, 6 downwards, so negative 6. And so 4 plus negative 6 is a result of negative 2. The next one is g minus f at negative 1. So I'm separating that into g of negative 1 minus f of negative 1. So again, I'm going to make a little mark here at the x value negative 1. What's the value of g at negative 1? Make sure you're looking at the right function. What's the value at g at negative 1? Okay, g is the blue graph, the line. So 1, 2, 3 down, so it's negative 3 minus. What's the value of f at negative 1? That's the orange graph. That's up 1. So negative 3 minus 1 is negative 4. The next one is f times g at negative 6. So again, I've separated it into f at negative 6 times g of negative 6. So I'm going to go to the x value negative 6. I'm going to make a little mark. So f is the orange graph. What's the value of the orange graph at negative 6? Okay, I'm going to climb 1, 2, 3, 4 up. Yes, so that's 4 times. What's the value of g, the blue graph at negative 6? Okay, I'm going to climb up 1, 2. So I have 4 times 2, and so the value of the multiplication function is 8. And then last but not least, I've got the quotient function. I've got g of 1 in the top. I've got f of 1 in the bottom. So here I'm going to make a little bit longer of a mark because my graph is getting crowded. So at the longer mark at x equal to 1, what's the value of g? What's the value of the blue graph? That's indeed true. Thanks for the confidence. And then what's the value of f at the orange graph at 1? 3. So -5/3, that doesn't reduce at all. That is done. Any questions, comments, or concerns? All right, so adding, subtracting, multiplying, dividing, I think that dovetails with your prior knowledge pretty well for this class. This is the new one, so I want to be able to talk about this adequately because this is super important if you're, for some of the stuff we're going to do in this class, but then going beyond this class in pre-calculus, the composition is what this is called, is really, really important. And so composition, I'm first going to define it. So if f and g are functions, like we're used to using, then we call this operation the composition. The composition of f and g is given like this. So here's the notation. F, this is a little circle. It's not a multiplication dot. So f composed with g. It looks like the word fog, but that's not an O. I'm just drawing it a little bigger so you can see it. So f composed with g of x. That's how you read it. So you can read this in one of two ways. You can read this as f composed with g. Or because math people are fundamentally lazy, instead of saying f composed with g, what they'll say is f of g. Okay, f of g. So if I just use the word of instead of saying composed with, that's just the math lingo. So I've got f composed with g of x. Now, this has no meaning to any of us. If you've never seen it before, you'd probably never figure out what it is. So here is how it's defined. Here's what you do. You take the function f, you start with it. They go in the same order. So it starts with f on the left side of this. So I start with f on the right. And then I'm going to put some parentheses. And inside the parentheses, I'm going to put g of x. Some books call these nesting functions. What you're doing is you're plugging one function inside the other. That's what it means to compose functions. So in this particular order, f composed with g, what that means is I'm taking g of x and I'm plugging it into the function f. Now, if that seems wild and wacky to you, it is, and we're going to do plenty of practice. That's why I wanted to get to this point in the class. So like we did previously, we're going to start doing this with values, and then we'll do this with general functions. Whatever questions you have are going to be good questions, so you should ask them, please. I love questions. Makes me know that you are thinking about this instead of just falling asleep. Okay, so here goes. Example 3, my example. We are going to determine f composed with g of 3. So first thing I always do, anytime I encounter a composition, my brain does not process the composition with this notation. So I seek to avoid that. So my first step is I'm going to rewrite this as f, because that's the first letter, parentheses, g of 3. Function composition just means you're plugging one function into the other. So this one, what I'm going to do first is I'm going to figure out what is the value of g at 3, and then I'm going to plug that into f. Now on this first one, I'm going to show you my scrap work. I'm not going to write this scrap work for all of them, but if you need to, that's fine. I'm going to come over to the side. I'm going to say, okay, well, what is g of 3? Let's do that. So when I plug the value 3 into the function g, what do I get? Yep, I get 3 squared, which is 9. Everybody tracking where that came from? Okay, that's something you already know how to do, but I know sometimes when we learn something new, the stuff we already knew also seems confusing. So here's what we do now. I'm going to take that value 9, that value of g evaluated at 3, and I'm going to plug that value into f. So another way of saying this is the output of g becomes the input of f. And now I'm going to take the 9, I'm going to plug 9 into the function f, F is 2 times what I'm plugging in plus 5. I'm plugging in 9. So 2 times 9 is 18, plus 5 is 23. Okay, so that's our first composition. A new skill. I'm assuming this is a new skill for everybody. If it's not, well, that's okay. You're just not what I assumed. All right, so do exercise 13. It's the same problem, but this time you're doing it with -2. So again, notice the order of my letters, because the next problem is going to kind of expand your horizons a little bit and see if you're catching on to this. So this one starts with F, and then I'm plugging in G evaluated at -2. So when I plug -2 into the function G, what do I get? Okay, so if you need to write, I guess I lied earlier, so I'm going to write this one more time. So I've got -2 squared, so that is equal to 4. So now I'm going to plug 4 into the function F. Is everyone tracking what's going on here? If you're not, and you're not asking a question, I don't understand why, so you please do. So 4, when I plug it in, 2 times 4 is 8, plus 5 turns out to be 13. So the next problem right below it, exercise 14, reverses the letters. Okay, so this time you're going to do G composed with F. So first thing to do is translate that into function notation that we're used to dealing with, and then go from there. At this time, I've reversed the orders of the letters. So I've got G first. Okay, we always just go in the same order that the letters are given in my composition notation. So G, and this time I've got F at -2. So F evaluate at -2. When I take the -2 and plug it up here in F, what do I get when I plug -2 into this function here? 2 times -2 is -4, plus 5 is 1. Anyone not see where the 1 came from? Anyone confounded about why the G is first on this one this time? Okay, so then G at 1 is 1 squared or 1. Great. Okay, well, I'm changing the functions just to make sure that you're doing all right with this. So do exercise 15, please. This is f composed with g at -2. So I'm going to do what's inside first. I'm going to take the function g and plug in -2. And so this one, when I plug the -2 in there, what is g of, let me write it right up here. What is g of -2? Yeah, I guess you're probably a little confounded because what are we doing with the square root of -1? Sometimes we call that I, sometimes we don't. When we're dealing with functions, we don't have any imaginary numbers right now. That's a whole different level of algebra called complex algebra. I fully recommend you take that class. It's amazing, but that's not the class you're in right now. So this one, since we don't, in our functions in our Cartesian plane, we don't have anything for the I, what we're going to do is we're going to say this one's undefined. -1, if you remember, is not in the domain of my square root function that we've been working with in this unit. All right, so I promise that the next one will be a little more interesting than that, or maybe you did find that interesting. Go ahead and do exercise 16 right next door. Okay, so this one starts with G, and then I'm plugging in f of 1 into that. So f of 1, when I plug 1 into this function right up here, 5 times 1 is 5, plus 4 is 9. So this becomes g of the value 9. Everybody with me and where the 9 came from and why it's inside the parentheses with the g? Are we doing okay? Great, I'm glad to hear it. G of 9, then when I put 9 into g, 9 plus 1 is 10, so I just end up with square root of 10. Don't give me a decimal, just simplify any radicals as they come. That one doesn't simplify at all, so you are done. You don't need to do anything else with that. Okay, so if you're doing okay with the numbers, then there's one more skill that we're going to talk about here, and that is what to do with when I'm not given a value, when I'm just doing this for functions in general. So I'm going to do the next one, example 4, and I'm going to compose f and g of x. So first step, I'm going to take f of g of x just like with the value. I don't do anything different here. Now I think this is where my habit of using parentheses wherever I see an x kind of has its payoff. Okay, so what I'm going to do is I'm going to take my function f and I'm going to rewrite it. So f is 5x plus 4. So my function f is 5 times whatever I'm plugging in plus 4. You with me so far? Now this time I'm not plugging in a value. This time I'm plugging in g of x. Well, what is g of x? What am I plugging in? Perfect. So right where that parenthesis is, I'm going to put a square root of x plus 1. And the same thing's true here as what I said when we multiply or divide or add or subtract. If there's any simplifying you can do, do it. If there's not, you're done. And the only thing I'm going to do here, you could leave it like that. It wouldn't be wrong. I'm just going to get rid of those parentheses because they're not really doing anything for me. So I'm going to write 5 times the square root of x plus 1 and then plus 4. I can't add the 1 and the 4. Please, I beg you don't, because the 1 is under the radical. The 4 is not. They're not like terms. You can't distribute the 5 because the radical is not a set of parentheses. There's nothing else to be done with that problem. If you've got a question, be sure to ask it. If not, I want you to do exercise 17. You're flipping the order of the functions. All right, so I've got G composed with f of x this time. So again, if you want to, I didn't do this on the last problem, but in case anybody had a little difficulty, what you could do, I just on this one, I just wrote what G was down here, but what you can do, if it helps, is take f of x, and f of x is 5x plus 4, and change the notation. If you'd like to do that, great. If you don't like to do that, it's fine either way. So what I'm going to do is I'm going to rewrite the function G down here. So I've got the square root of x plus 1. So what I'm plugging in, plus 1. This time what I'm plugging in is f of x, or in other words, 5x plus 4. So wherever there was an x in the function g, which I've now made a parenthesis, I'm going to put 5x plus 4. This one, I do have a very slight thing that I can do to make this look a little better, and then I'm done. I have like terms because everything is under the radical, so 4 plus 1 is plus 5, and we're done with that problem. Anybody got a question, comment, or concern? All right, on the next one, I've changed the functions. There's going to be a little bit more that you can do to simplify on the next two, because I want you to have as much fun as possible today before I lose you for the weekend. So do exercise 18. Okay, so for exercise 18, I've got f composed with g of x. Once again, if it's helpful to you, you can substitute the g of x as x squared minus 2. Either way, what I'm going to do is I'm going to take the function f and I'm going to rewrite it. So f is x plus 3. So f is x, whatever I'm plugging in, plus 3. In this case, what I'm plugging in is g of x, or in other words, x squared minus 2. So I'll put that right there. And I do have some like terms on this one. So I've got x squared, and then minus 2 plus 3 is plus 1. Anybody make a misstep that we need to talk about? All right, well then flip the order in exercise 19. You're doing the functions in the reverse order. Okay, so this one, I've got g that I'm starting with, then I'm plugging in f of x. Once again, the value of f of x that I'm plugging in, f of x is x plus 3. So I'm going to take my function g, which is x squared minus 2, and I'm going to rewrite it as whatever I'm plugging in squared minus 2. And this time what I'm plugging in is the value of f of x, which is x plus 3. Well, there's a little bit of simplifying I can do on this. I can do x plus 3 squared. Please do not make the algebra mistake of just squaring and saying this is x squared plus 9, because that's not right. We've got a FOIL, so I'm going to come over here on my scratch work, and I'm going to say, okay, x plus 3 squared is x plus 3 times x plus 3. And when I FOIL that, I get x squared plus 3x plus 3 more x plus 9. So that's x squared, 3x and 3x is 6x plus 9 minus 2. And so this composed function is x squared plus 6x plus 7. Anything we have to address before we hit the last page? All right, last page. Here we go. Again, we're just reverting back to reading graphs because reading graphs is such an essential skill for us in this class. So we're going to use graph 2 to answer some problems. Okay, so what I would like you to do is do the first one. We'll just do these one at a time. So for graph 2, do f composed with g of 2. This time I'm just using the graph to find the values rather than being given the function. So for this first one, f composed with g of 2, I'm going to take f and I'm going to plug in the function g evaluated at 2. Keep in mind that f is the blue graph and g is the black graph. So here goes. G of 2. So here is the value 2, x value 2. What is g's value at the x value 2? Negative 2, yes, it's the black graph, so down 2. So I have f of negative 2. So now I'm going to go back to the x value negative 2, so 1, 2. And what's the value of f? What's the value of the blue graph at this position? 1, 2, 3, 4. That is indeed true, negative 4. If you got a question, be sure to ask it. If not, move on to the next one, g composed with f of 4. This one is G composed with f of 4. So the first thing I'm going to do is I'm going to go to the function f. I'm going to go to the blue graph. I'm going to evaluate it at 4. So my x value 4, 1, 2, 3, 4. What is the value of f at the x value 4? Okay, 1, 2, great. So I'm going to take G and I'm going to evaluate it now at 2. And I think we just did that in the previous problem. So x value 2 and the value of G, which is the black graph, is 1, 2 down or negative 2. Are we doing okay reading the graph? All right, well then the last one, the purpose of this last example is to show you that the functions don't necessarily need to be different in order to compose them. So do G composed with G of 0. This is G composed with G of 0. So don't, I understand that it might be confusing the first time to do this, but just follow the same procedure. First thing I'm going to do is I'm going to go to the function G and I'm going to plug 0 in. So G is the black graph. So at the x value 0, which I've just made a little red mark here, what's the value of the black graph at 0? Yep, don't be shy. It's 1, 2, 2 up. So I have G of 2. So then all that we do, the only difference here is now instead of going to a different graph, we're going to look at the same graph at the x value 2. So over here, 1, 2, it's weird how they all worked out to have a G of 2 in them. So this turns out to be negative 2. Anything that we need to talk about? If you have something, please bring it up. If not, I don't want to bore you. So go over to the next one and do f composed with G of negative 2 of the other graph, please. So this one is f composed with G of negative 2. So I'm going to start with the function G. G is the purple graph. So I'm going to go to negative 2 right here. And the value of G, the purple graph, is 1, 2, 3, 4. So that becomes the value that I plug into f. F is the green graph. And so I'm going to now look at the value of the green graph at the x value 4. So here's the x value 4. And we see that the green graph is 1, 2. So I get the value 2. You got a question, ask it. If not, do the next one, G composed with f of negative 1. This one's G composed with f of negative 1. So I'm going to look at the function f, which is the green graph at negative 1. So here's negative 1. And what do I observe about the green graph? Doesn't exist it there. It's undefined. So this is very similar to the problem that we did with the equations. When I plugged in negative 2 earlier, I got the square root of -1. This one right here is undefined. -1 is not a value in the domain of that composition. All right, one more, because I know that might be deflating. Do G composed with f of 0. I've got G composed with f of 0. So I'm going to start with the green function, and I'm going to evaluate it 0. So here's the x value 0. What's the value of the green function at the x value 0? It itself is 0. Yes, it's right down there at the origin. So now I'm going to evaluate the purple graph at 0. So at that same place, what's the value of the purple graph? Great. All right, the last thing we're going to do, just because I want to make sure you see a little bit of anything you're going to see on the homework or that I would potentially ask you on the test, is what happens now if my values are defined in tables instead of graphs or instead of equations. So let's go ahead. You're just going to learn as you go on this one. Give the first one a try. F composed with G of 3. All right, I got F composed with G of 3. So I go over to the table that defines the values of G. And what is the value of G at 3? Right here, it is -2. So now I'm going to plug that value into F. And what is the value of F at -2? Okay, it is right here. You are exactly right. It is 1. Okay, so we're using 2 different tables. Okay, I'll give you a couple moments to go ahead and do the next one. G composed with f of -2. So according to my table, when I do G composed with f of -2, what's the value of f at -2? We just did that one. So yes, that turns out to be 1. Okay, and then what is the value of G at 1? It's right here. The value of G at 1 is equal to 2. One final problem for the day. Then I'll mention a couple things about next week, and you'll be free of me for 5 days or so. All right, this last one is f composed with f of 4. So I've rewritten that in function notation. So firstly, what is the value of f at 4? Yep, it's right here. It's the bottom of the table. The value of f at 4 is equal to 2. And so then again, I use the same table because it's the same function. What's the value of f at 2? It's right there. It is equal to 3.